Hi, my name is Amraj Shugu, and I'm back again for the first summary video of my Learnings at web3bridge course 4. So last week we talked more about data types, and more importantly, we implemented these data types in a few smart contracts that we wrote. So I'm going to go over our thought processes on one of the smart contracts that we wrote, and then explain what's really happening there, so that we can understand. Yeah, so let's get right into it. So this is a vault contract, and in a very basic way, I'm going to explain it. So just think of it this way: government want to grant a few businesses, give a few businesses grants, and I was given the funds, so I'm the one to disburse this funds to these businesses. So I have the money somewhere, probably in a suitcase, and I am meant to create a contract that creates beneficiaries, which are the businesses. And while creating this contract, I am specifying the business, the amount the business will receive, and a few details. So basically, while creating a beneficiary, I specify the amount and the details of a particular beneficiary. So, and also, I don't want a particular beneficiary to be able to withdraw the funds once I create the grant. So I want them to wait for a particular time to pass before they are able to receive their funds. And also I want them I also want to keep track if they have withdrawn all of their funds or part of it, right? So this is just like a basic way of explaining. So going into the smart contract. So what this one my smart contract will do, I want a contract where the owner creates a grant for a beneficiary, allow the beneficiary to withdraw only when time elapses, and allow the owner to withdraw before time elapses. So this means that okay, during the wait time or the elapse time for the beneficiary, probably I want to do more checks on this business, and if they don't actually meet a particular criteria, I can withdraw their grants even before the elapse time reaches. Right, so that's what this line 7 says. Allow owner to withdraw before elapse time and get information of the beneficiary. So get the information that I use in creating a particular beneficiary, right? And then at the end of everything, get the amount of ITA in my smart contract. So remember, when I'm creating this beneficiary, I'm actually funding my smart contract. So later on, when a particular time elapses, then this beneficiary can now come and withdraw their funds in my smart contract. So basically, my smart contract is what's holding this fund, and it is the vault, right? So going over the state variables, I have an address of owner. So this is me, because I'm the one to create this beneficiary. So this is the contract, and this is the contract owner, and I'm going to define this owner in the constructor, which is basically a function that runs once during smart contract deployment. So once I assign this owner a value, I cannot assign it again because this function runs once. Then creating this ID here, what actually means is I want to create a unique identifier for my smart contract, for my beneficiaries. So I want them to have unique IDs. Beneficiary 1 has ID 1, beneficiary 2 has ID 2, and so on and so forth. So these beneficiary properties is basically the details of a particular beneficiary. These are the details I collect um, from a particular beneficiary to be able to create grants for them. So this amount allocated is the amount that I am allocating to a particular user. The beneficiary is the address of the user. That's where the funds will be withdrawn to when the beneficiary comes to take the money. And this time just keeps account of the elapsed time for a particular beneficiary. So if this time doesn't pass, the beneficiary won't be able to withdraw the funds, or else this time passes. And this status keeps track if a particular beneficiary has withdrawn all their money or part of it. Okay, so this mapping, just see this mapping as a container or like a database of all my beneficiaries. So it keeps track of the whole beneficiary that I'm going to be creating. So if I create beneficiary one, I throw it into this mapping. I create beneficiaries, so I create it into this map. So it's a container for all my beneficiaries. This only owner, this is a modifier that I'll be using to modify a particular function to ensure that only the owner will be able to call that particular function. So it's just saying, check if the current person that is calling this smart contract is the owner, which I defined in my constructor, right? If this is true, then continue with the rest of the code. That's what this underscore semicolon says. Continue with the rest of the function that it is modifying. Else, throw this error, not owner. So then uint ID. So this is an array that is storing. This is the array of my ID. So I said I'm creating a unique identifier for my beneficiaries. So this array here is just keeping track of these IDs. So if I have like 10 beneficiaries, so this uint ID is an array of whole of my IDs from 1 to 10. So likewise, this beneficiary properties, this is also an array of struct, which is an array of all my beneficiary details. So the same way this is holding the IDs, this is actually holding the beneficiary details, which is this struct that I define here for every particular beneficiary. So this is also another modifier that is checking if a particular time for a particular beneficiary has elapsed. So if this passes, then the beneficiary is allowed to withdraw the funds. But if this doesn't pass, it tells the beneficiary time not passed. Right. So this is blocked or timestamp. This is a global variable in Solidity or in Ethereum that tells us our current time. It tells us our current time. So I'm checking if block.timestamp is greater than or equal to block.time. So if our current time is greater than the elapsed time, which is a time that I set, if that time that I set is already in the past, which simply means that the time has passed, and or if it is equal to it, that means it's just like a second is exactly equal to it. So the next second is okay to withdraw, right? So, but if this doesn't pass, tell the beneficiary time not passed. So this is the constructor I've been talking about, right? So I'm here during smart contract deployment. I am setting this, and I'm setting this. So I'm saying the particular address that is deploying this contract should be set as the owner of this contract. Yeah. So this is a create grant. Um, this is a create grant function. So it's saying create a grant with a particular beneficiary and an elapsed time. So this beneficiary here is just the person's address because this is what the person will use. I mean, the business will use to interact with our smart contract. So that's why we are using the address here. And the time, I've already said that it is our elapsed time. And we are making this function payable because we want it to accept Ether. So I'm creating a grant. I am passing in an amount of Ether for a particular beneficiary that will be stored for that particular beneficiary in our smart contract. And it is external because I want it to be called from outside of the contract. It can only be called from outside the contract, not from inside or just only in the contract. So this only owner simply says only the owner can call this function, and this returns um, shows that I am returning. Okay, this is too large. Let me try. Reducing it. So this returns a UINT. So this UINT is the particular beneficiary ID. That's the unique ID that I created for this beneficiary. So what really happens here? So I'm checking that the message of value, which is the amount I'm calling this smart contract with, this particular function with, is not zero. So I don't want to create a beneficiary with a zero amount allocated. So I'll check for this. So if this passes, continue. Beneficiary property storage BP. So this storage here simply says that I'm trying to modify a storage variable, right? Which is a struct. No. This is a struct to be sure, right? Okay, beneficiary properties. Let's not take chances. So beneficiary properties. is here. So yeah, it is a struct, right? So this is a struct. So I'm saying beneficiary properties at okay. Now I understand, right? So this beneficiary property, this I'm initializing a variable here, a storage variable. So and the value that I'm assigning to it is an ID in our mapping. So currently at this line of code, this particular value in our mapping is empty, right? So I'm saying I'm mapping at a particular ID, which is this ID here. No, not this one, not this one. Where is it? Okay, which is this our ID here, which is our unique identifier. Remember, our mapping is a mapping of UINs to a struct, right? So I'm saying that this BP is a pointer to our mapping at this particular ID. So, so if I'm now using this pointer, anything I'm modifying this pointer, I'm modifying that particular mapping at a particular key, right? So I'm saying BP dot amount allocated like this. So I'm saying BP dot amount allocated is equal to let me go back again one step. So I'm saying BP the amount allocated is message of value, which is actually the value that I'm calling this function with, right? And then BP dot beneficiary is this our beneficiary, which is an address, and then BP dot time, which is this time that which is a parameter here, which is this, and then UINs is our our state variable ID, which is this. So then so I'm pushing in I'm pushing in that particular user ID into the array of ID that I defined up there, and I'm also pushing this particular struct into our array of structs I defined up. So I am incrementing this. So because I don't want to come and create another beneficiary with the same ID of the one I just created. So I am incrementing it here, making it unique. So and I'm finally returning my ID, right? So which is the ID of the particular user I created. Um, yeah, that's it for my create contract. So basically, I am pointing to an empty. I'm pointing to an empty key, a key that is not holding any value. Basically it's the default, which is zero. It's holding zero at this point. So when I'm setting it here by assigning BP dot beneficiary, BP dot amount allocated, and BP dot time. So the next is the withdrawal. So um the withdrawal is at the point after I'm done creating these beneficiaries. I want them to be able to withdraw their funds after a particular time has elapsed. So that's why I'm using this as time elapsed here, and it's also external because it will be called from only outside our contract. And I'm passing in the ID. So this ID here is the unique beneficiary identifier, and then an amount, right? So why we have this amount here is because the beneficiary can choose to withdraw part of the grant or all. So this if the person wants to withdraw all of the money, the person can easily pass all of the funds here or pass part of it, right? So but if we just wanted the user to withdraw all of the money, we could just ignore this and then set the money that we will send to the user as the total money they have. But then we want to give them that flexibility um, to withdraw all or part of it. Then going over this again. So we are setting this BP a pointer to our mapping at this particular case. So this BP is just holding a particular user's details at this particular key in our mapping, which is the key that we are passing here, which is an ID to a particular beneficiary. So I'm saying that I'm just setting a local variable here, user, which is going to hold the address of that particular beneficiary. Then I'm using it here. So I want to check if a particular beneficiary if a particular user that is calling this withdraw function is a beneficiary. So I'm checking this user, which is the address of a particular beneficiary in our smart contract. Is it equals to the message of sender? So message of sender is just basically the address that is interacting with our function. So if we find this user, if we find this particular method of sender to be equal to the user that is stored in our mapping at a particular key, then we are good. But else, you are not a beneficiary for a grant, then you can't withdraw from us. So then we also setting the of amount the user have in total. So this is the amount allocated. That means the total amount that was allocated for um, a particular a particular beneficiary. So that is what this amount is holding. So you are now checking. We want to also we actually want to save gas for our user. We don't want you to come and withdraw zero funds. So we are checking if the amount that you passed in is zero. If it is zero, we notify you that your withdrawal amount should not be more than zero. So we prevent you from going through this ones. Just reverting it here and prevent you from going through this other lines of code by notifying you. Then if this passes, we are good. Then we go to the next require. So you are saying BP.status is not equal to false. So um, while creating a particular user, we are checking, we are setting the BP.status, which is that have this particular user withdrawn all their funds. So we are setting it to be false because at the point of creating this creating a particular beneficiary, they haven't yet withdrawn their funds. So withdrawing their funds is false. So we are checking if it is false. So if it is false, fine, we are good. But if it is true, that means you've already withdrawn all your money. So why coming again to withdraw something that you don't have anymore? So that is it. So if this passes, fine. If it doesn't, you don't have any money left in this vault. So we tell you that, then you go. Then we're also checking that our amount. So this is also checking that we've already withdrawn all of our funds. So I'm checking amount is greater than zero. So I'm checking the total amount a particular beneficiary has in our contract is greater than zero. That means you should at least have something more than zero to be able to withdraw. Or just tell you have no money. So if this require passes, then we are good. And we are now saying um, require that the amount the user wants to withdraw is less than or equal to the total amount they have. So you're free to withdraw all of your money once, or you're free to withdraw part of it. So that's, but at the end of the day, we're just checking that the amount you're passing in that you want to withdraw is not more than what you have. You cannot give more than, you cannot take more than you have, right? So if this passes, that's cool. But if it doesn't pass, then that means you don't have any money. You're either you don't have more, you don't have what you want to withdraw basically. So that's what this line is saying. So then if this also passes, then okay, you're close to withdrawing. Then balance. So this balance is just basically what I'm storing here, what will remain after you withdraw your money. So assuming you have 10,000 and you want to withdraw 5,000, so this balance will hold 5,000 because once you withdraw, you have 5,000 left. So that's what this balance is holding. So at this point, I'm setting a storage. I'm setting the storage here about updating the beneficiary's balance to this. So I don't want to make your I don't want to leave I don't want to let you have 10,000 even while you've withdrawn half of it. So I want to update the storage by using this pointer. Remember that this pointer is pointing to a storage here, which is the struct of a particular user in our mapping. So if I update this, I'm fine, right? So here I'm also checking. So I'm also keeping track that a user has withdrawn all of their money. So if my balance is zero, that means you've exhausted all you have in our vault. Then I'm going to toggle your status to true. That means when you get to this point, you receive this. You don't have any money in this vault, right? Then okay. Then the next okay, not done with this. So this get balance is a function. So I want to get balance of a particular user. So where did I define get balance? Okay, I'm getting the balance of my smart contract. So I also want to be checking that my smart contract has this money that this particular user wants to withdraw, since it's the vault and it is what is holding this money. So I want to check that this money that this user wants to withdraw is actually in my smart contract. So that's what this line is actually doing. So how do you get the balance of a smart contract? Address this. So this here is simply saying the address of this smart contract dot balance. So this returns the balance of our smart contract. So at this point, if balance is greater than the amount, right? So I'm checking that the balance, what we have in our smart contract, is greater than what the user wants, the beneficiary wants to withdraw. So if this passes, then at this point, we now transfer this amount to this particular beneficiary. Passing all our checks, then you're eligible to get your funds, right? So I also want to point out something which is here at line 81, no, at line 80. So we ensure that we updated the value. We updated we update okay, it's actually line 81. We ensure that we updated the balance of our beneficiary before sending funds. So if we don't do this, our contract is vulnerable to reentrancy, right? So we ensure that we update the value of the balance of our user before transferring. So the user can't get to this transfer um, before updating the value, the balance of the beneficiary. So this particular code here simply prevents our contracts from um, reentrancy attack. So this reverse grant, this is the point where the owner of this contract can revert the ben- can revert the grant for a particular beneficiary even before the elapsed time. So, as I was saying earlier, so this simply gives the owner the ability to withdraw the money that was allocated for a particular beneficiary. So, this is still a pointer to a particular beneficiary. So, we pass in that particular beneficiary's ID that we want to revert their grant for, and then we point to it in our mapping because our mapping is a container for this detail. So we want to be able to update this value that we have in our mapping for this particular user. And then the amount we have, this is a pointer to the beneficiary's details, and we are storing the amount of that particular beneficiary in this our in this our variable here, right? So then we are setting the the allocated amount for that particular beneficiary to zero. So then we are now transferring that particular amount to the user that was earlier allocated to this particular beneficiary to our owner. So the owner gets the fund. So that is what our revert grant is doing. Then okay, this is just a simple function that is just returning the um returning the details of our beneficiary. So we are just basically assessing our mapping here at this particular ID. So we specify the key that is holding this particular user's details, and then we return it, right? So we are why we don't have a return inside this function is because if you define a variable in our return block, automatically once you assign a value to that particular variable that we define here, it automatically returns it. So it just saves us one line of code. So we're just saying beneficiary properties memory BP. So, and we are setting that BP here. So once this is set, it automatically returns it. So it's also external because we are calling it from outside our contract. And then it's a view because we are just viewing um, a data from our state. We are not modifying it. So it's just a view. We're just looking. Then returns something. So get the balance of our smart contract or vault. So get balance. Okay, I think I've gone over this. Yeah, this really gets the balance that we have in our smart contract. And this public, so this public creates just simply means you can call it from inside or outside of our smart contract. So it is public because we can call it from inside, from outside, and it is you can also call it from inside, just like we did in our withdrawal. somewhere here. Yeah, because we called it both in inside and out, internally and externally. So that is why it is public view. Just we're just viewing a state, and then it's returning a UINT, which is our balance. Then get all beneficiaries. So we basically want to get um the whole data, the data of all our beneficiaries. So that is what this contract does. So remember, we had an array of ID and also an array of struct, right? So and pay attention to this. We also define the variable in our return function. So this simply means that once we set this particular variable, it returns the value that was set into it. So, and this also helps us such that we can, and notes, this return will only is like the last line of code that we execute in this function. So it's our function first deal with whatever that is inside, and at the end of dealing with everything, it returns a particular value that was assigned to this. So let's go over this. UINT memory or ID. So we're just initializing an array of UINTs. So we just call it all, and we're assigning ID to it. So this ID, remember, this is the states variable, the states array that we define here, which is array of IDs of our beneficiary. So we are just creating a local variable for it. So what's the point of going to the state every time to get this to get the elements in this ID? So to save gas, um we just assign whatever everything that inside our state array of ID into a local array. So we won't have to keep going back to our state variable. So it's costs more gas to do that. So we just make use of our memory variable here. So this BP2, it's so this BP now we are just this we are creating a local array. We are initializing a local array, and this is the syntax for it. So and when creating a local array, we must have to know the strength, the length of our array. So we cannot create a dynamic array inside the function, but we can create a static array inside the function. What makes an array dynamic and what makes it static? A static array has a distinct length. That means if it's an array of length 5, it can only contain 5 elements. But our dynamic array can contain as much as any length, right? So, but then we can only create a local static array in our local um, as a in our function, as a local variable in our function. So this is just what we are doing here. So we are creating a new static array with the length of our ID. So if you had 10 beneficiary, the length of this particular array will be 10, right? And it's an array of structs. So then for us to fill in our BP, for us to put things into our BP, so we are using the for loop. So notice here that our I is equal to 0 and our I is less than all dot length I plus plus. So we're just saying since our since our key is starting from 0, we want it this all dot length is 10. So we want to iterate from 0 to 9, so which gives us a 10 iterations, right? Then here we're just saying beneficiary property, which is our mapping that holds all our beneficiary details. So, and we are setting a key. So this key, how are we getting this key? So we have our all, which is an array of our IDs. So all at position I. Remember that our ID, we instantiated it to be 1, right? We set it to be 1. So the first element in this all array is 1, 2, 2, 3, 4, and thereabout. So, and since our I here is 0, we can't put I here because if you are trying to access we are all at position I, which is zero. Won't be okay. If you're trying to access beneficiary property at key zero, we don't have any value there because our key in our mapping started with one, which is a unique ID. We started with one, so we don't have any value at key zero, right? So that is why we are using all as position I. And you know that all at position I will start from one, two, three, four, and thereabout. So that is why we are using this here. So by the time we are done with our loop, this our BP will be filled with all the details of our struct and then we return it. So this is basically all we have in this contract. And thank you for if you watched to this point, thank you for sticking around and look forward to getting another summary video from me this time next week. Thank you.